Well, hello everyone. I am Beth Kimani, and today we shall be exploring AI and machine learning, predictive modeling, and we shall do a deep dive into random forest regression. So today we shall, from our previous topic, we had dealt with decision trees, but today we are going to go deeper into random forest regression. So um, we shall start. And uh, there is one thing about random forest regression, and random forest is one of the most widely used machine learning algorithms in the real production setting. And random forest regression is one of the most popular algorithms for regression problems, and that can be predicting continuous outcomes because of its simplicity and its high accuracy. And I'll give you like a gentle introduction to random forests and also the reason behind its popularity. So that's what we shall handle today. Yeah, let's brace ourselves. It's going to be an interesting ride. So I'm going to share my screen. So deep dive. So yeah, this is what we shall be going through today. So we'll have just a deep dive into machine learning. Yeah, let's see how it goes. So like I said, I'll start with the definition. So we shall do the theoretical foundations, and then we shall do the why ensemble learning, then the architecture, then the bootstrapping and bugging, then the feature randomness, mathematical objectives, and then we shall have a live code implementation. We shall have a hyperparameter tuning, and then we shall do interpretability, and then we shall have hands-on or and a question and answer session. So yeah, so let's do this. So as I was saying, a decision tree, uh, like I'd said, from decision trees we get to form random forest regression. So a decision tree is like an expert who memorizes a specific book but can't handle a new story. And they are highly sensitive to small noise in the training data. So they're highly affected by higher variance. And trees grow deep to capture every detail, and the result is always a great test for accuracy and also for real world prediction. So yeah, let's dive in. So um so let's start with an actual how would random forest be described in like layman terms? So let's start with like an actual problem, right? So imagine you want to buy real estate, and you want to figure what comprises a good deal so that you're not taken for granted. So yeah, the obvious thing you do would look for historic prices of houses in the area, and then create some kind of decision criteria to summarize the average sales prices given in the real estate specifications. So you can use a decision chart to evaluate whether the listed price for the apartment you're considering is bargain or not. So it could look something like this. Let me show you. Hope you can see it. Yeah, it could look something like this. Yeah. So um, so if you look deep, so we have the located in affluent. Is it located in like an affluent? Is the house located in like an affluent area? So if yes, does it have more than 2 bedrooms? So if yes, yeah, it can range in a price of 420,000. Or if no, it can be ranging at $280,000. So going back, let me see if I can add um no, there's no way. So uh is it located in an affiliated area? So if no, is it close to other facilities? So if yes, it's ranging at 140,000. So if no, it could be ranging at 880,000 uh, $80,000. So yeah, uh, so give me 1 second. So back here, so I'll reshare this. Um, share. Yeah, so here you can see that the chart represents a decision tree through a series of yes no questions, which lead you to like a real estate description. So could be 3 bedrooms, and it is to historic average prices, and you can use the decision tree to predict what is the expected price um, of real estate will be given its attributes. So yeah, that's what I was trying to cut across. So yeah, um, so so now if we would go deeper, a random forest regression algorithm takes advantage of the wisdom of the crowds, and it takes multiple but different regression decision trees to make them vote. So we can a random forest. It's like I had explained earlier. A random forest regression is made from various decision trees. So each tree needs to predict the expected prices of real estates based on the decision criteria it picked, and then the random forest then can calculate the average of all the predictions to generate a great estimate of what the expected price of real estates should be. So um, another question that you come across when you're being asked on what is the business use cases of random forests. So um, let's just check. Uh, so um, um, random forests are used to solve like a variety of business problems that a company can needs to predict a continuous value. So when a company needs to predict a continuous value, then we use random forest regression. So one, we can use random forest regression to predict future prices or costs. So whenever your business is trading products or services, say for example raw materials or stocks or maybe labor or surface or service offerings, then you can use random forest regression to predict what prices to use, what the prices of these products and services will be in the future. So it can also be used to predict future revenue. So what I'm trying to say is that you can use random forest regression to model your operations. So for example, you can input your investment data, that is maybe advertisements or sales materials or costs of hours worked on long-term enterprises deals, etc. And your revenue data and also random forests will discover the connection between the input and the output. So this connection can be used to predict how much revenue you will generate based on the growth activities that you pick. It can be marketing or direct to customer sales or enterprises sales, etc., and how much you're willing to spend on it. So the final thing we can use for random forest regression can be, say, comparing performance. So imagine you've just launched a new product, right? And the problem is it's unclear whether the new product is attracting more and say it's having a higher spending. So is it attracting more customers than the existing product line? And so you're going to use uh, random regression to determine how new products compares to your existing ones. So in a nutshell, a random forest regression is extremely useful in answering interesting and variable businesses questions, but there are additional reasons one why it is one of the most used machine learning algorithms. So, what are some of the advantages of random forests for real production applications? So, random forest regression is a popular algorithm, like I said earlier, and due to its many benefits in production setting, uh, and due to this, it has many benefits in production settings. So one is that it's extremely high accuracy. What do I mean by this? So, thanks to its wisdom of the crowd's approach, random forests regression achieves extremely high accuracies, and it usually produces better results than other linear models, including linear regression and also logistic regression. So, another thing why uh, it is uh, it's productive in real production is because it scales well. So computationally, an algorithm scales well when new features or samples are added to the dataset. So that's how easy it is, and also the fact that it is very interpretable. So although it is not as easily uh, explainable as its underlying algorithm, decision tree regression, random forests inspected can be inspected to output the decision trees which are used in like the final decisions. So the individual trees can be used to understand what the important decision nodes are, and as well as prompt questions allow around what led to like the final prediction. So yeah, I see we are two. Hi Charles Kuria. Let me give you um, how are you? I think you can unmute yourself. Hi Charles. Okay. So yeah, so I was saying it's very interpretable. So, and another thing is it is easy to use. So random forests work for both categorical and also numerical data. So um, what I mean is so you spend less time one hot encoding or you spend less time one hot encoding or labeling data, and it is not sensitive to most missing data, and it can also handle outliers to a certain extent. So overall it saves you time that you would otherwise be that would otherwise be spent in, say, cleaning data, which is usually the biggest step in any data science pipeline. So you have to like have clean data, but with random forest regression, this saves you so much time. And this doesn't mean that you should skip the cleaning stage entirely. You will often obtain better performance by working the data into an appropriate shape. So if you put your data in its best shape, you're going to get the best results. But random forest does make it easier to use and also faster to deploy and reach the base model. Yeah, so I'll also take you through machine learning approaches to random forests. I don't know if I have it here. Let me just check. Mm-hmm. Don't think I have it. Um, no, I don't have it. But random forests regression is, as you all know, it's a supervised learning algorithm, and it is also an ensemble algorithm. So it is supervised in the sense that during training, it learns the mapping between inputs and outputs. For example, an input feature, say for an independent variable in the training dataset, would be specifically that an apartment has, say, 3 bedrooms. And the 3 bedrooms is like a feature, the number of bedrooms. And this maps to like the output feature or the target, that an apartment will be sold, say, at 2000 $200,000, and this is the target, that is the price sold. Hope uh, we are together up to there. And also, um, uh, ensemble algorithms combines multiple other machine learning algorithms. So in order to make more accurate predictions than any underlying algorithm could on its own. In the case of, say, random forests, it ensembles multiple decision trees into like a final decision. So random forests can be used for both regression tasks, that is to predict continuous outputs, such as, say, prices, or classification tasks. So you can predict categorical and discrete outputs. So here we'll take a deeper look into using random forest regression predictions. So one thing we need to learn is that um, random forests follows a two-step process. So it builds n decisions. I think I have that on my slide. So I think it's in my second. Hmm. Let me see. So it uses the n decision tree regressions. That those are the estimators. So the number of estimators labeled as n, capital N, defaults to 100 in like Scikit-Learn, the machine learning Python library, where it is called n estimators, and the trees are built following the specified parameters, e.g., minimum number of samples at leaf nodes and say maximum depth that a tree can grow, etc. etc. I think I'll share something. So, and also we have said it follows two steps. So the second step is average prediction across estimators. So each decision tree regression predicts like a number as an output for a given input, and random forest regression takes the average of those predictions to its final output. So I think I'll share this tab. So I hope you can see. So this is what I'm trying to say. So you can see we have a test sample input. We have first decision tree, second decision tree, and so many more decision trees up to decision trees, say 600. So we have a tree being classified, being branched. So we have the branches, we have the decision nodes, and we have the leaf nodes, which are the last nodes. So the same root node, branching, decision nodes, branching, and then finally the sorry then finally we have the leaf nodes. So this is our first prediction, our second prediction, and predictions, and then prediction 600. So we will come up with an average of all predictions, and then we shall come up with a random forest prediction. This is the best definition of how a random forest predict how a random forest regression tree is built. So yeah, so we can go deeper onto like how uh, random forest regressions are built, and then we shall do a hands-on to like solidify what we have been doing. So um so like we have seen in the diagram, uh, a random forest regression is made up from decision trees. So a random forest regression cannot exist without decision trees. So we have the attribute selection. So a decision tree regression algorithm looks at all the attributes and their values to determine which attribute value would lead to like the best splits. So for regression problems, an algorithm looks at the uh, mean square error. So let me just share. Let me just reshare that screen again. Here, share. So this is what I mean. Oh yeah, this is the n estimator, the parameter. So uh, does many always mean better? So this is what I was trying to talk about. I looked for this slide and I couldn't find it. So this is where I am at. So um, so I was saying the decision tree regression algorithm looks at all attributes and also their values to determine which attribute value would lead to like the best split. So for regression problems, the algorithm looks at the MCE, what we also call mean square mean square error, and as its objective or cost function, which needs to be minimized. And this is equal to variance reduction as a feature selection criterion. So note that Scikit-Learn also has the mean absolute error implementation here. So the average physical error. So that is the mean absolute error. So the other one is it finds the best split point candidate. So it splits the data set to to it splits the data set at the value, so which is called the root node, and it repeats the process of attribute selection at other ranges. So the third part is the algorithm continues iteratively until either one, we have grown terminal or leaf nodes, so uh, so that they can reach each sample. So there is no stopping criteria, and uh, So I've said it continues iteratively until, so either it has grown, we have like a grown terminal, or we have reached some stopping criteria. So for example, we might have set like maximum depth, which allows a certain number of splits from like the root node to the terminal nodes. And or we might have like set a minimum number of samples in each terminal node to like prevent them from splitting beyond the criterion point. Yeah, so that is basically it. I think we should delve into hands-on. Yeah. uh, but before that, I'd love to answer a question on you might be asking yourself, what is so random about random forest regression? It's an interesting question, right? So, um, let me share. Let me just share this tab. So this is what I was trying to say. So we have uh, like a bootstrap sample, another bootstrap sample, another bootstrap sample, and then we have decision tree 1, decision tree 2, and 3. Let me just expand it a little. And then we have like a random subset of data, so with some replacement, and then some random feature subs feature subset at its split, and then a random feature subset at its split, and then we will come to like an average, and then we'll have the final prediction regression value. So um let me see. So I'll answer the question, what is so random about, say, a random forest regression? So um uh it's easy. So the algorithm randomly selects a subset or features. So uh, um, and these features can be used as a candidate at each split, and this prevents the magnitude of decision trees from relying on the same set of features, which automatically solves problem number 2 above, and decorrects individual trees. So another thing is that each tree draws random samples of data from the training data set, and when it's generating the splits, and this introduces a further element of randomness, so which prevents the individual trees from overfitting the data. Remember, in decision trees, our main challenge is always overfitting. So uh, the fact that we introduce a further element of randomness reduces the overfitting of data. So since we can't see all the data, we can't overfit it. So that is the rule random forest regression uses. So yeah, so just like decision trees, it specifies the maximum depth of trees, and it also increases or decreases the number of estimators, and also it can specify maximum number of features to be included in each node split. So we shall do a bit of hands-on. So yeah, we shall use Jupyter notebooks, or if you're conversant with Google Colab, then that is what we shall do. So yeah, um, give me 1 second. So I'll use Jupyter notebooks. Let me just create a new notebook and then we shall proceed from there. So let me share. Let me just create a new kernel. So let me share this tab. Yeah, so give me 1 second, then we shall go on. Give me just 1 second. So yeah, so we shall do a hands-on. This is always my best part. And we shall use a professional Python script using Scikit-Learn. And this code uses a built-in dataset, so you can run it immediately during whenever. So we shall import libraries. So importing, one thing I insist is writing comments as you code. So libraries. So we shall import numpy as np, import numpy as np, and then we shall import matplotlib as plt. We shall import matplotlib. Oops, sorry. Matplotlib dot pyplot as plt, and then we shall also import Scikit-Learn datasets. So from Scikit-Learn.datasets, we shall import Fetch California housing. So we shall use the dataset known as Fetch California housing. So from Scikit-Learn, Learn, we shall import datasets. Sorry, I misled you there. We're going to import Fetch California housing. So fetch so this is the data set we are going to be using. So we shall also ensemble. So from scikit-learn.ensemble, we're going to import random forest regression. So random forest regression is stored in scikit-learn.ensemble. So from sklearn .ensemble, we're going to import random forest regression. And then what we shall do next is we are going to have like a model selection that will help us train, test, and split. So from sklearn.model selection, so from sklearn dot model selection, we're going to import tests, train, and split. So what we shall do next, we shall, from sklearn.metrics, we are going to import mean squared error and also R2 score. I'll explain what this line does. So from sklearn, uh, dot metrics import, we're going to import mean squared error and R2 score. Mean squared error and R2 score. Yeah, so those are the libraries we shall use. Yeah, oh, I was to explain what the first line does. So what the mean squared error does and what the R2 score does. So it is mostly, these are evaluation metrics, and they measure the average of the squares of the errors. Sorry, so a lower number means the model is more accurate for mean squared error, and for the R2 score, it tells how much of the variance in the data our model explains. And if it is a 1.0, it is the 1.0 is the perfect score. So yeah, so I think we have ran into an error. Let me check. It is wrong. Okay. Oh, I left an S here. So oh, I misspelled this. California housing Soran. Random Forest Regressor. Model selection. Import train test split. So train test split. Yeah, we're good. So that's part of debugging. So yeah, let's go on and we load the data set. So what we shall do here is loading the data set. We shall use is equals fetch California housing. So give me 1 second. So we shall give data is equals to fetch California housing. So here, Control C, Control V, and we put empty square brackets there. So we shall also have the variables x and y. Yeah, so we shall run that. Perfect. So what we shall do next is we shall split data into training and testing. So splitting, we shall split the data for training and testing. And testing. So this is something we have done so often, so it won't be such a hard thing. So we shall do x train, x test, y train, y test. So x train, comma, y train, x train, x tests, y train, y train, y tests, and then we shall do the train test split. So we shall equate it to and then what we shall do is we shall do an x, we shall do an so yeah, so we've put our test size to 2%, and then we shall put our random state at 42. So yeah, and then we shall initialize and train our model. So initialize, let's run this, see if we run into any problems. So we shall do initialization, initialize and train. So what we shall do is we shall give our model, we shall give our model into the random forest regressor. So the random forest regressor, and then we shall give it an n estimate and shall give it an n estimate, sorry, we shall give it an n estimate of 100. So estimators will be equal to 100, and then we shall have the maximum depth, which will be equal to 10. So max depth. So this is how far our forest can actually grow. Depth will be equal to 10. And then we shall do a random state as well, which will be equal to 42. control. Yeah, so I hope we are good up to there. So, and then we shall now make predictions. No, we shall fit our model. We shall fit our training, because we are training, so we shall fit our model into X train and Y train. So that, and then let's run, see if we shall encounter any errors. So we're good. So what we shall do next is we shall make a prediction. So we shall make some prediction. Uh, so predictions. Oops, sorry. Which you shall do model dot predict the X test. So model dot predict. Sorry, predict X tests. So yeah. So sorry, I forgot to put. Yeah, so we shall do some predictions. So let's just run that. So what we shall do next is we shall evaluate the model. So we shall see what it can do. So evaluate the model. And how do we do that? We shall do the mean squared error. We shall do the we shall put that in Y test and predictions. So we can call it MCE. Then we say mean squared error, sorry, mean squared error. Then we do the Y test and predictions. Predictions. Perfect. And then what we shall do is we shall do the R score. So we are trying to do the evaluation using mean squared error and the R2 score. So we shall give a variable R2, and then we shall say R2 score shall say R2 score, and then we shall also equate it to the same as the mean squared error. Just then Control V. So let's run that. Oh, sorry. Yeah. Nice. So we're just going to like print. Let's just print and see what happens. Sorry. Control. Yeah, so let's just print it. Yeah, so there we have it. So you remember what we said about proximity. So if it's closer to 1, you remember we said that if the R2 score is We said the R2 score tells us how much variance in the data our model explains. So if it is a 1.0, it is the perfect score, but our R2 score came to 0.7737, and our mean squared error gave us a 0.29. So you remember our mean squared error just measures the average of the squares of errors, and a lower number usually means that the model is more accurate. So since we have a lower number, is such a low number because it's like a 0.3, it's low, so we have the perfect score. So what we shall do next is we shall actually uh, show the feature importance. So show feature importance, show feature importance. So, and what this does is so we shall do some importances, and let me just, I had done it before, so I wanted us to code together, but since we don't have so much time, I'll just copy and paste it, but I'll explain what happened. Yeah, so here we have it. So let me just explain what happened. I know some of us are like, but what happened? So the model feature importance, it's a powerful like deep dive. It's a powerful deep dive tool, and it ranks which variables like median income had the biggest impact on the predictions, helping us understand the logic behind, say, the AI. So what I do is uh, I'll create a GitHub README that you guys can clone and run if you're not able to like keep up with the coding. But yeah, so let's see if um we can do like a visualization. Mm. So I think we shall. I don't think we have so much. Uh, let's see if it's going to run. If it does, well and good. If it doesn't, it's still okay. So let me run. Let me just run every cell. So and then we shall. Give me 1 second. I want us to like see if we can. If it fails, we won't do it. If it works, then it's fine. Yay! So there we have it. So let me explain the line. So here all I just did was, let me just add a comment. So what I did was I just did uploading predicted versus the actual values. So we are plotting predicted versus actual values. So predicting between predicted and actual values. I don't know if it generated. Yeah, actually it did. It really did. So yeah, so let me rerun it. but it's fine. So here you can see the predicted values and the actual values. So you can see the ranking, and we can also have like a seaborn that shows us the average bedroom. So it could be the number of bedrooms, the importance score. So here we have the importance score I was talking about. We have the population. So these are the feature names, and these are the like importance scores. So yeah, you can see the importance ranking there. So this is great. It's actually great. Yeah. So the deep dive into uh, this has helped us like to like collect the relevant data. We have explored the data to discover patterns. We have trained our random regression model, and we have also evaluated the model with variety of metrics. So yeah, that reminds me we didn't look into this. So you see the feature importance, you can see the medical, you can see the house age, you can see the average rooms, you can see the average bedrooms, population, average occupation, the latitude, and also the longitude. So yeah, this is the best that we could have learned about random forest regression. Yeah, and it's amazing. Yeah, that's basically in a nutshell what random forest regression is, and how we can implement it. So I'm going to reshare this. Let me just reshare. Let me just reshare this. So yeah, we have gotten to like go through everything here. So yeah, so I have an assignment for you. So we have learned that random forest regression is many trees plus random data plus random features. So that's in simple terms what random forest is, and it is like it is one of the most robust out of the box algorithms. Yeah, so I have an assignment for you. Try to improve the R score in your Scikit-Learn dataset. And thank you for joining Google Developer Groups, Chuka University AI ML track. So see you next week.